Hello, fellow. My name is James Owusu-Appiah, and I believe in innovation and doing things differently. This video has been prepared for you to guide you through some well-known concepts that will aid your studies and preparations towards exam. Due to COVID, we cannot meet in person to discuss, so I hope this video finds you well and helps you achieve excellence. Thank you.
This is a JOEA initiative, and we're talking about Thevenin's theorem. What Thevenin's theorem is about, the whole idea of Thevenin's theorem, and why do we even use Thevenin's theorem. So let's kickstart. So Thevenin's theorem is just a normal way of solving circuit problems, usually to find the voltage and the current across a load. You understand? But there are some key points that make Thevenin's theorem different. One, it works only with linear circuits. That's one point. Linear circuits, I mean circuits where voltage is directly proportional to current that follow Ohm's law. You understand? And two, it works for both complex and simple circuits. See, sometimes you have circuits with a lot of sources, a lot of parts, parallel, delta, star, and all that. It works for the simple ones we are aware of. And three, the main aim is to give an equivalent circuit consisting of a voltage source which is in series with a resistance and a load. You get me? So let's let's look at this. So we have figure, let's call this 1a, and let's call this figure 1b. So you see, the idea of the Thevenin's theorem is to convert the question we have been given, which is this part, you understand, to this. This is the Thevenin's resistance, and this is the Thevenin's voltage. We represent them with VTH and RTH. So we have been able to convert this circuit on my left hand side to this simple circuit on my right hand side. You get me? So that's the main idea of the Thevenin's theorem. It's used in solving circuit problems. But first, we have to convert that circuit you have given us into a Thevenin's voltage in series with a Thevenin's resistance and the load. So let's go to this one too. Let's call this figure 1c, and let's call this figure 1d. So the same idea here. The one on the left, you see, is complex, consisting of two current sources and a voltage source with some resistors layered across. So with that one, we are trying to convert that one to just a simple voltage, which is called the open circuit voltage or the Thevenin's voltage, in series with the open circuit resistance or the Thevenin's resistance and the open part AB. You understand? So we have converted that whole part in the dotted box, you get me, into VTH in series with RTH. So with that, it will be easy for us to solve the equation for the current and the voltage across AB. So steps in solving Thevenin's theorem. So we have brought about 6 steps, simple steps that you can follow. So the first one is you open the load resistor. Usually they'll give you a question and they tell you find the current through a particular load, maybe 5 kilo ohm resistor or something. So first, that part they have told you, you just open that part. You understand? You open circuit it. And two, you calculate or you measure the open circuit voltage, which is what the Thevenin's voltage. You understand? So in doing that, you just put your VTH in that open part, and you'll be able to take loops and solve it and get the value. Let's move on. Step 3. Next, we'll have to calculate the open circuit resistance, also known as what? The Thevenin's resistance. And in calculating that, there are some things we have to do. You understand? For the VTH, you just open that part, you put your VTH there, you do your normal current distribution, and you find your VTH. But with RTH, there are some few things you have to take into consideration. So the first one, in calculating RTH, you have to short circuit all voltage sources. That's really important. You have to take notes. You have to, let me put asterisks there. Short circuit all voltage sources, and you open circuit all current sources in the circuit. After you do that, the parts that current will not be passing, you take note that they won't form parts when you are finding the RTH. You get me? So you do that, and after that, you find your RTH. So five, after you have found your VTH and your RTH respectively, you convert that circuit they have given you now to what we call the Thevenin's equivalent circuit. It consists of just three major things: your open circuit voltage, which is your VTH, your open circuit resistance, which is your RTH, and your load resistance, which is usually RL. So that's the reason why we find VTH and RTH, so that those are major components of the Thevenin's equivalent circuit, which helps us to solve for the current and the voltage using Thevenin's theorem. So, point 6, you calculate the current through the load resistor using Ohm's law. Ohm's law. So, RTH will be equal to RT will be equal to RTH plus RL, where RTH I'm just using it to represent what the total resistance in the Thevenin's equivalent circuit. You get me? Thevenin's equivalent circuit, that's the circuit you get at the end. So we use Ohm's law because you see Thevenin's theorem will work for only, as I said, linear circuits. Linear circuits are circuits that will be Ohm's law, which is voltage directly proportional to current. So you take the loop, you see in the end the circuit will just be consisting of VTH, RTH, and RL. So you find your total resistance, which is RTH plus RL, and your current will be your VTH divided by your RT, or VTH over RTH plus RL. You get me? So those are the six major steps you have to go through. So let's take this example. This is a simple circuit, and we are supposed to find, let me change the color of the pen. We are supposed to find the current IL and the voltage VL through the load resistance of 5 kilo ohm. That's what we are supposed to do using what? Thevenin's theorem. So we start. Let's use the steps. So step 1, open the load resistor. So you see the load was here. Now we have opened it. That's step 1. That's the first thing to do. The place that they want you to find the unknowns, you open that part first. So that's what you have done. And after that, you calculate your for your VTH. So in calculating for your VTH, you have to do your current distribution. We know that VTH is what? An open circuit what? Voltage. So when you put it there and you open that part, it means what? No current will be passing through. So this section, let me show by dashes. You see, that's where your VTH is. If current is supposed to pass through here, it's not possible because every open circuit has got infinite resistance, and current will always take the least resistance path. You get me? So this is the right way where I've shown the I. You see the I is coming, and the I comes here, and the I goes back. So it means that this part of the circuit, there won't be what? Any current passing through that side. So let's move on to step 3. So in finding, first we have to find the I. So in finding I, you take this path, this loop. So that's what I showed here. 48 volts is equal to I into bracket. You see the 12 kilo ohm and the 4 kilo ohm resistors will now be in series. You understand? Because of the open circuit we had here. So they will be in series. This one and this one, they will be in series. So you add them up, and after that, I will be equal to the 48 divided by your 16 kilo ohm, which gives you what? 3 milliamps. So now we know our I. So now we know our I, we have to find our VTH using the path that VTH belongs to. So looking at the diagram, you see VTH consists of, if you are taking a loop or a path, it will consist of the 8 kilo ohm and the 4 kilo ohm. You get me? Let me change the pen. To consist of the 8 kilo ohm and what they call it, the 4 kilo ohm. You get me? So that will be the loop we will take. But remember, no current is passing through the 8 what kilo ohm resistor. You understand? So when you are taking the loop, so from here, you see that the voltage VTH will be the same as the voltage across the 4 kilo ohm resistor. The reason being that no current will be passing through what? The 8 kilo ohm resistor. So we come here, we write the equation for that path. So 0 times the 8 kilo ohm plus the 4 kilo ohm times the 3 milliamps we calculated for. And that will give you your VTH. This is a very important thing, so you take note of it. That's why it's in red. So after that, we find our RTH. And as I said, RTH, we have to go with some specific lay down rules. We short circuit what? All voltage sources. So you see, there was a 48 volts voltage source here, but we took it out. Now it's represented with a short. You get me? And after that, we look through where we open circuit the load resistor from. You understand? So from looking through it, you'll see that now 12 kilo ohm and 4 kilo ohm are in parallel, because we can what? Transverse across it, across those two resistors, without coming into contact with any other resistor. So you see 12 volts and 12 kilo ohm and 4 kilo ohm. You see, you can transverse across them without coming into contact with any other resistor again. So it means that what, they are in parallel. And after that, their effective resistance will also be in series with the 8 kilo ohm. You understand? So let's go to the solution. So this is it. They are in parallel. 12 in parallel with 4. Then their effective resistance in series with what? 8. You get me? So after that, in the end, our RTH will be what? 11 kilo ohms. So after that, step 5, we redraw the circuit. We redraw the circuit. So in redrawing the circuit, the VTH we found in series with our RTH, in series with our RL, which was the load resistance we were supposed to find. So this is what we call the Thevenin's equivalent circuit. The Thevenin's equivalent circuit. Someone will ask, maybe I didn't see step 4. We made step 4 and step 3, because in finding RTH, you have to do step 4 as well. Yeah, so now this is what we have. This is the Thevenin's equivalent circuit. So Thevenin's theorem, all we want to do is to get this simple circuit. That's why we go through all those stress in finding VTH and RTH just to get this. So after that, this is a series circuit, and this obeys Ohm's law. So step 6, which is the final step, find the load current by Ohm's law. So our VTH is what? 12. So that's here. Then our total resistance, because they are in series, RTH is in series with RL, we add them up. So this two, we add them up. So when we add them up, we get the effective resistance for the Thevenin's equivalent circuit. Then after that, we divide. What do we get? 0.75 milliamps. So that is the current flowing through the load. You understand? If you test it right now, if we had a circuit and we have joined it on a board and we use an ammeter to test it, this is the value we'll get. Considering all things being equal, this is the value we get. And the voltage will be, the voltage for the load will be the current through the load times the resistance of the load. You get me? So when you multiply the two, you get 0.75 times 5 kilo ohms, which gives you what? 3.75 volts. Understand? So that's basically what Thevenin's theorem is about. Just get the concept, you get the steps right, you follow the steps, and you'll be fine. So you can leave your questions in the comment section and we'll get back to you. Thank you.